In our first lab, we will learn to use the MSP EXP430 FR5739 FRAM experimenters board, the out-of-box experience, and the graphical user interface available with the hardware are also discussed. If you plan to execute the lab, please make sure you have an FRAM experimenters board and a digital multimeter. Please follow the instructions shown in this slide to obtain the software required for the lab. Out of the box, the FRAM experimenters board comes pre-programmed with the user experience code. The MSP EXP430 FR5739 FRAM experimenters board is an evaluation module for MSP430's first FRAM MCU. The development kit is equipped with on-board emulation, accessible pin headers, connections for RF data cards, and on-board analog sensors such as a 3-channel accelerometer and an NTC thermistor. User input is obtained via two switches, S1 and S2, and a variety of results can be displayed using different combinations of the 8 available LEDs. The board is available today for $29 from the TIE store, and we will be using it for all the FRAM labs that follow. The FRAM experimenters board is equipped with a user experience code that demonstrates the key features of FRAM's technology and the FR5739 device specifically. The user experience code consists of 4 modes. Each of these modes are selected by pressing switch S1. Entry to the modes occurs on pressing switch S2. To return back to the menu, S1 is pressed once again. The experimenters board interfaces with the PC through the backchannel UART to display the output when in any of the 4 modes. The output is also displayed using the 8 LEDs that are on board. However, during a power measurement, it is important to turn off the LEDs and the UART data stream so that the result display does not impact the power numbers. This is done by toggling S2 when inside a mode. The 4 modes are high-speed FRAM write mode, flash emulation mode, accelerometer sample and store mode, temperature sensor sample and store mode. In the high-speed FRAM write mode, the application writes to MSP430 FRAM at the rate of approximately 2 megabytes per second. The write function fills up the memory in 100K blocks, after each of which an LED is turned on. In the flash emulation mode, the speed of flash erase and write, which was derived from an MSP430 F2274 device, is displayed on this board. This speed is then used to emulate a flash erase and write event on the FR57XX device. As in the first case, the LEDs are cycled sequentially for every 100K bytes written to FRAM. We can easily see from the demo that FRAM write speeds at approximately 2 megabytes per second is 100 times faster than flash write speeds at approximately 13 kilobytes per second. The third and fourth modes use the onboard analog sensors to collect accelerometer and temperature samples that are then stored on the fly in non-volatile memory. This was previously not possible without RAM buffering in flash-based devices, since the speed of flash write erase was significantly slower than the ADC sample frequency. This slide shows a screenshot of the graphical user interface that is available with the FRAM experimenters board. The display shows an FRAM write speed on the left in mode 1 and flash write speed on the right in mode 2. The screen also shows the remaining endurance of an FRAM segment while executing continuously from within a mode. The frames per second data that is displayed on the top right corner indicates the speed at which the PC interacts with the user interface. If this is a very small number, then the user interface will most likely not track the real-time changes on the board. Remember that the user interface requires the latest version of Java to be installed in the PC, and this is available for download from www.java.com. Now we can take some time to play with the modes, selecting between various modes with the switches S1 and S2 and observing the output. This concludes the first lab in the FRAM training workshop.